brothers here. This is a video on introduction to stoichiometry. Basically, stoichiometry is calculations and reactions. So, to explain it simply, I'll say it's like questions like if I have this much of this reactant, how much product will I get? Or if I have this much product, how much reactant will I need to make this reaction work? And questions like this. An example of this is here. How many moles of iron oxide will be produced from 62 grams of iron? So this is a basic stoichiometry problem. We've got the equation here. As we can see, we need 4 moles of iron for every 3 moles of oxygen to form 2 moles of iron oxide. So this equation's already balanced. That's the first step. I'm not going to include it in this video because on tests and stuff you need to balance equations before you can do calculations in stoichiometry, but this isn't a video on balancing equations. If you don't know how to balance equations, go watch a video on that, but we're going to get straight to calculating because the equation's already balanced. So what I'm going to write first of all is the molar ratios. So what molar ratios are is what I'll explain here. What I've wrote here, it's very important. What we've seen here is for every 4 moles of iron, we're going to need 3 moles of molecular oxygen to produce 2 moles of iron oxide. Okay, so this molar ratio here is actually very important because it's telling us if I have this many moles of this, I will need this many moles. If I have this many moles of this, I will have this many produced. And it will say we need double the iron to produce, there's going to be half of iron oxide produced if there is moles of iron. So basically, this is very important. The question's asking us how many moles of iron oxide will be produced from 62 grams of iron. So first of all, before we can try to jump into this question, first we have to work out what 1 mole of iron is. And if you simply look at a periodic table, I believe 1 mole of iron equals 56 grams. I think it's something like 55.8 or something like that, but I'm going to round up for this. If you don't know what a mole is, go watch a video on that. It's basically, if we have this huge number, if we have 6.02 times 10 to the 23rd atoms of iron, that will weigh 56 grams. So that's 1 mole of iron equals 56. So this is going to be a good point to start. We have 1 mole of iron is 56 grams. Right, so now, but the question's saying we have 62 grams of iron. So 1 mole would be 56. But we have 62, so we're going to have a little bit more than 1 mole, right? 1 mole is 56, but we have 62. So what we're going to do is we're going to grab out the calculator. We're going to go 62 divided by 56. 62. Let me get that up. 62 divided by 56 is going to give us an approximation. I'm going to approximate this. So it's going to give us 1.107 moles. So 1 mole was 56 grams, but we have 62 grams, and that's going to give us this much here. So if we had 56 grams of iron, we'd have 1 mole. We have 62 grams, therefore we have 1.107 moles. Right, so we have a bit more than a mole. Now, if we look at our question again, if we have how many moles of iron oxide will be produced from 62 grams. So basically what it's asking us is how many moles of iron oxide will be produced from 1.107 moles of iron. 62 grams can be interchanged with moles. So that is the amount of moles. 62 grams of iron is the same as 1.07 moles. Of iron. So basically, if we look at our molar ratio here, for every 4 moles of iron, we're going to need, for every 4 moles of iron, we're going to have 2 moles of iron oxide produced. So basically what it's saying is we're going to have half iron oxide produced as we have iron. So we're going to half the amount of iron, the amount of moles of iron we have, As we can see, 4 to 2, we're going to half it to give us how many moles of iron oxide we will be producing. As we can see, the molar ratio, what we've done first, we've converted grams to moles. We've worked out since we have 62 grams, we're actually going to have 1.107 moles. And now we're looking at the molar ratios. What we're going to do is divide 1.107. 1.107 divided by 2 is going to give us 0.5535. Therefore, we will have 0.5535 moles of iron oxide produced, right? So we're going to have 0.5535 moles of iron oxide produced, which makes sense. You know, we have it's going to be half of the moles of iron we have, and if we half 1.107, we're going to get 0.5535. All right. So the question asks us how many moles of iron oxide will be produced from 62 grams of iron. We've done that. We've found the amount of moles produced. We've got this many, 0.5535. That's answering the question. However, if the question, we've finished the question. However, if the question asked us how many grams of iron oxide will be produced from 62 grams of iron, all we got to do is convert back to grams. We got to figure out how many grams, this many moles of iron oxide is. So first what we're going to do is find out how much 1 mole. We're going to do the same as we did with the iron. We're going to figure out how much 1 mole is. So as I said, 2 times, iron oxide has 2 iron atoms in it. It's 56 times 2, plus we got 3 oxygens, and grams per mole, we're going to have 16 grams for every mole of oxygen. So that's 16 times 3. So there we're going to have 112 plus 48. It's going to give us 160 grams. So for every mole, 160 grams per mole of iron oxide, right? So we can see for every mole of iron oxide, we're going to have 160 grams. However, in the equation, if we have 62 grams of iron, we're only going to have about half a mole. The 160 grams is a full mole, but we're going to have 0.535. So it's very easy to do this conversion. All we're going to do is we're going to go 160 times 0.5535 is going to give us how many grams of iron oxide will be produced. So we're going to go 160 times 0.5535 is going to give us 88.56 grams. Well, 88.56, but that's how much grams of iron oxide is going to be produced. The question asks us how many moles. We've solved that, but if it asks how many grams, we've worked this out. What we've done is we've figured out how much 1 mole of iron oxide would be. That's 160 grams per 1 mole, but the equation says the equation where we have 62 grams of iron says we only have around roughish half a mole. I'm not saying that number again. We roughly have half a mole, and that sort of kind of makes sense because if we look, 160, divided by 2, it's going to give us around 80, right? So we've answered the question for moles. This is how many grams will be produced. This is the introduction to stoichiometry. Thanks for watching.